For those of you guys looking for a repair video for this particular unit, well, you're in for a disappointment. This is not a repair video. This is an evaluation and a inventory check to see what parts I need to get this unit up and running. It's an old receiver. It's from the 1960s. It's full of tubes, so we know that it's going to have bad caps in it, and this is precisely the reason why we always use our dim bulb tester when powering this old equipment up. This exact reason. Check it out. Some receivers are more desirable than others to collect, and this one is certainly one that is on that list of receivers to collect. If you can find one of these or its bigger brother, you're in good company. This is a Sansui 500. It's a vacuum tube receiver. The Sansui 1000 was its bigger, more powerful brother. But other than that, the features that they share are very, very similar, other than the power output and, of course, the tubes that are used for the amplifier. This one here, I'm just going to check this over, check the controls, so forth, see how it is. We'll look at the caps in it, see what needs to be done, and then down the road, if we need to recap this all, we'll do that, but I'm not going to do that in this video. This is just an initial inspection. So first things first, let's lift the top off of it. Nice. These units were multi-voltage units. You could operate at 100 volts, 117, 220, or 240. Now our voltage here is typically at 120, but it's a 117 volt tap, so that extra 3 volts is not going to hurt anything. The receiver is broken down into 2 stages. This is the tuner section, the radio section, and the power amplifier is over here. It's a push-pull design, and this unit here would produce approximately 15 watts per channel. So it's not a particularly high power unit. The 1000, I believe it did around 30 watts per channel. But this is the lower power version. 15 to 20 watts is all you're going to expect to get from these tubes here. And of course the tubes on this one are 7189A tubes. If I'm not mistaken, the Sansui 1000 uses 7591 original tubes, which is the same as my Macintosh uses. I'm going to power this thing up. I'm going to power it up slow on the dim bulb, and we'll watch it power up. Make sure nothing's drawing too much power. Let the filter caps charge up slowly, and then we'll just see what it does. So I'm plugged into the dim bulb tester. I notice that the power button appears to be kind of bent on this. You know what? I think the switch is bad. Yeah, it's got a broken switch. Again, I don't know a lot about the history of the unit. The fellow that brought it to me, I think he just picked it up. So I don't know whether he really knows what's going on with it. But the power switch is not switching. So here's the bottom. We'll check that power switch out. Well, the switch itself is very, very stiff. I'm just going to give it a shot of cleaner and see whether that will maybe unstick the switch, because it's really, really stiff here. Let's give it a little shot of cleaner, and we'll just spin it around here. Yeah, that's a little better. This is not a volume control, it's a power switch, but it's a weird type of switch that just turns. It turns, you push it. Now it's pushing. Okay, let me put the button cap back on and see whether it's like someone maybe got jammed at one point, but I think that it's kind of bent a little bit, but it's kind of been bent this way a bit. I can see that, but it's not sticking anymore. Maybe if it can be, I don't know if it can be bent back. It's kind of bent out down, pointing down this way a little bit. So I don't know if this can be bent a little more straight. The front face here. That's better. That's better. Okay, let's see if the switch is working. So is it on or off? Let's just put the meter on here and see whether we've got continuity. Okay, it's open, and I press the switch. So the switch works. It was just jammed. It's off, on, off. Okay, great. Let's turn it over and turn it on and see if this thing makes any noise. This is a hybrid. There are some transistors in here. Most of these caps in here are oil filled. And the oil that's in these is going to be PCB oil. So you don't want to just toss these ones in the garbage. These big caps here that are all oil filled, it definitely will be PCB containing oil, because they all contain PCBs back then. But it doesn't have paper condensers or anything in it. So they should, most of them for the most part, are probably okay. I mean, you can go crazy and you can change them all out. That's not a problem. For someone that wants to go crazy, there's not that many that need to be changed out. Let's power it up. Here's the power applied. We can see the dim bulb tester up in the top corner of the frame there. We'll just hit the power button and see what happens. I don't see anything. I don't see it drawing any power. Okay. Looks like we do have a problem. Now remember, I said the power switch is good. If I put my meter across here, the switch is on. Therefore, when I put the meter across the power cord, I should see continuity, but I see nothing. It's open. Completely open. So, somewhere along here, we have a problem. Could be a blown fuse. I guess we can check the fuses. There's a fuse holder on the back here. Let's just check for a, well, it might help if there's actually a fuse in the damn thing. Well, that might explain why it's not turning on. It has no fuse. According to the tag on the back, it takes a 3 amp fuse. Therefore, a 6 amp fuse will work just fine. That's what I'm putting in. And that's only because that's all I have, but that's okay. That won't be an issue, because I'm going to have it going through my dim bulb tester, which is going to limit my current to just under 1 amp anyway, so we don't have to worry. We don't have to worry about damaging anything. Nothing will get damaged because I have current limiting with the dim bulb tester. So once again, let's apply power. So that's lighting up bright, which is normal because the capacitors are not charged. That lamp should go down in brightness as things start to charge up and warm up. And hopefully we will hear some sound coming out of the speakers if they're on. And you may hear something out here. Tape monitor's off, loudness off, stereo muting's off, AFC is off. As this thing warms up, we do expect to hear something. Now the bulb brightness is going down, which is indicating that things are starting to charge up. We can check for some voltages here. That would be the first thing, to check to see if we've got any DC voltages on the capacitors, and these are going to be very high voltages in here. So let's just check them out carefully. Vacuum tube stuff is one of the things that makes me a little nervous. That's why I don't have a watch on now. We'll just check for some voltages here and see whether we've got any voltages. 179 volts, 145 volts. So we know that the power supplies, the B pluses, are there. 111. So we got power. Therefore, we don't have any shorted diodes or anything. That's the first thing you think of when you've got a blown fuse like that is, why did it blow? Well, sometimes you'll get a shorted diode. It'll draw way too much current and pop the fuse, but that's not the case, because this is, it's drawing what type of current I expect that it would draw. We've got all the heaters and everything heating up for the vacuum tubes, right? So it is going to draw some power. And we do have voltage, therefore we should be able to get some type of noise out of this thing. If I can figure out how to work it. Okay, that speaker should be on. That's a good sound. Let's see here, tape muting. I guess I could plug my, why don't I plug my MP3 player or something into the auxiliary input, and we'll see if the amplifier part works. We'll try that first. Okay, I've got my auxiliary plugged in. These controls are really dirty. Now it's not going to sound great because we're running at low voltage. If I flip the full power, because I think we're okay. Those controls need to be cleaned for starters. So let's deal with the switches first and the controls. I did remember reading something on here about not using it on energized circuits. Oh well, I never was one to follow the rules. Let's get some cleaner into the volume control. Control next, which is the balance control. Bass and treble controls need to be cleaned. Tell you, sure easy to run out of power with a low power amplifier like this, especially with speakers that aren't that efficient. Crank the bass up. Of course, these units use a back in the day when everybody was using units like this, your speakers were usually a lot bigger and a lot more efficient than a lot of the modern speakers. But it sounds decent. We'll deal with the other switches on it as well. I'll just turn it back onto it. That's my patch cords are a bit loose. Gotta watch this area. It'll bite. I think what I'll do before I turn it over is I'll turn off the power. That way I don't accidentally hit something and get jolted. And these will jolt you, that's for damn sure. Tube circuitry is not very forgiving. Make sure everything's pushed in tight. There's other controls up top here that I do need to change, or do need to clean. So I'm going to pop this top cover off so I can get to the input switch because, well, we heard that it was noisy. And then we'll see what's going on with the radio section. So 2 Phillips screws hold this part together. Turn on the power again. And we'll clean the controls, these switches. Okay, the AM radio works. That noise is the plasma. How's the FM radio work? test transmitter, but it's working. Put my hand back here somewhere where the antenna goes, so I'll get a bit better reception, I'm sure. But see the stereo light down here, lights up in white.
Brought to you by Envision Financial. Get advice based on the size of your dreams, not your account.
We got a distortion on the left channel. Probably got a tube that's out here.
McDonald's has the gift that keeps giving. To Peter.
More likely one of these tubes is out the outputs. That shouldn't have started humming like that. That's why I cut the power off right away. Something else is up with this unit. So I noticed a little bit of red plating on this tube here. We may have a coupling cap that's going bad. That's why I cut it off so quick, and I put it back onto the dim bulb tester just to keep the current down when that hummed there. We probably have we could have a bad plating or bad blocking cap on this side, or the tube itself could have a problem. But first things first of all, I'll swap the tube over. I'll swap these two tubes around and see whether I get the same effect on here. Of course, monitoring it very, very carefully. But I think we're probably going to have to change out some of the blocking caps in here that are probably going a bit leaky. Again, that's to be expected. This is kind of just the preliminary look at this to see what needs to be done. The radio is working. We know that part's working. The amplifier is working. I did get that hum. That's probably what popped the fuse, was because the tube went into overconduction. And you want to stop that right away, because if you let that continue, not only can you burn out your tubes, but you can also burn out the transformer. But the tube itself may have an internal short in it, and that's what I'm going to do. I'm going to swap them around and see whether the fault stays on this tube here, or whether the fault goes to this other one. I'm just letting it cool down here for a few minutes because, you know, the tubes are going to be a bit warm, and we'll check that out, and then we'll go from there. As you can see, these tubes here do have lots of hours on them. You can see just right through here, the black that's showing up here, that's just from the tube itself in operation. They are long in the tooth, these tubes. They look like they might be originals or NEC. So these may have been original tubes in this unit. I'm just letting this warm up again. I'm going to look to see if anything starts to glow red, the plate on the tubes. I don't even need to put sound through it for this. So far, nothing. Oh, this one's starting to go. This one's starting to get red here. So I just cut it down there. Yeah, this one's starting to go bad, or starting to heat up. So we have a bias problem, and this tube has been driven into over bias. So let's flip her over and take a look underneath here and see what's going bad on this one. So what typically causes red plating of your output tubes, especially if it's only one, is that one of these blocking capacitors, I believe that's this one here, 0.3 microfarad at 350 volts. There's 4 of them, one for each of the output tubes. There's one, that's for the tube that was actually getting warm, so this is likely the one that's gone leaky. The other one is this one here for this tube, and then you've got another one up here for this tube and another one up here for this tube. And these will all be changed, like all these are going to be changed out. When we get down to doing the overhaul, I gotta first of all get the parts. So basically I'm going to do an inventory, but these electrolytics I think should all be changed out on this unit here. Again, it's not that many of them, but they really do need the oil-filled ones probably are not going to be an issue. These ones over here, but again, we'll change them out just for the hell of it. This was a Suzuki. This is a Suzuki cap. These are probably bipolar. These ones. They're not. They're non-polarized. They don't have a positive or a negative. So I'm going to have to source these. I don't know how long that's going to take. I'll have to source them, see if I can find them. I'm going to do an inventory because I have to let the fellow that owns this know what he's looking at, and I would have to recommend that we do change the ones that are, well, at least the ones in the tube, the blocking caps. So we should be changing this 1 microfarad here, that one, that one, that one, that one, that one, that one, that one. These ones here, at the least, at the very least. Some of these oil-filled caps probably aren't problematic, but you might want to just change them anyway while we're in here. It's not that difficult to clip them out and put new ones in, right? It's fairly straightforward on a receiver like this. The ones that are mounted to these little circuit boards sometimes could be more difficult just because, well, you got to pull the board out, and the board's got wires going to it, which is going to limit how far you can move it. So some of these ones might be a little more of a challenge to change out, but they also may not be bad. But it wouldn't hurt probably to change this one out too. It's a 500 microfarad. This one down here that you guys can't see. It's a 500 microfarad, 15 volt. Well, we'll be going to a 470. This one here. Anyway, I'm going to take an inventory of all these caps that I think should be changed out on this, and then we'll pick this up for a second part and do the restoration once I get a hold of the fella and kind of give him an idea as to what he's going to be looking at, because some of these caps are going to be, like, some of these are going to be relatively expensive, especially if you get into the audiophile ones where, you know, I've seen some of these stupid capacitors where, you know, they're asking $30-40 for one. It's crazy what some of these places want for these high voltage caps. But we got to do it, so that's what's going to happen. I'm going to take inventory, and we'll pick this up for a second part when we get the parts, so that we can go ahead and recap this receiver. I think the resistors are probably okay. The way that popped like that, I think this cap probably is internally shorting. And we can certainly, I could put this on my breakdown tester, but we won't do that now. We'll do that later. For now, let's close this one off. We'll get the parts and pick this one up once I have the parts in stock. So this is the shopping list that I need. I need a 0.3 microfarad at 350 volts, 4 of them. A 1 microfarad at 150 volts, 2 of them. A 40 microfarad at 300 volts, 1 of those. A 0.005 at 600 volts and a 0.022 at 600. 50 microfarads at 50 volts, 2 of those. 0.05 at 400 volts. A 200 microfarad at 50 volts. 20 microfarad at 180. 20 microfarad at 350. Both of those will probably get changed out with 350s or 400s or whatever I can get my hands on. 0.05 at 400. 0.3 at 250 times 2, and 0.02 at 400 times 2. So that's what we need. 21 caps. That's just the high voltage ones. See, these other ones, I will have some smaller ones like this, but the smaller ones probably aren't going to be as big an issue as these other ones that really do need to be changed. So I'm going to button this up at this point, put it back away, and talk to the guy that owns it, and find out what his plans are, how much money he wants to spend on this thing. And these type of restorations generally tend to be a little bit more involved, because you're changing a lot of parts. But I'm sure he's going to go ahead with it, and once I can source the parts, that's the issue right now, is sourcing a lot of these parts. There's only one shop left around that may have them. I'll have to go down and see. Go down to Lee's Electronics basically and see what he's got, whether he's got what I need. Otherwise they'll have to be ordered in, and I don't like ordering in parts just because that's going to add an extra $30 or so in shipping at least, and broker fees, maybe more, to order stuff like this in. So I really don't like having to do that, because I have to pass those charges on, and when someone has to pay an extra $30 or $40 in shipping charges to get some parts shipped out, well, that sometimes is a tough pill to swallow for many people. Anyway, I'm going to close this one off right now with my shopping list, and we will pick this up for a second part once I get the parts in. I don't know when that's going to be. It might be a month from now. It might be 6 months from now. I don't know how far away the parts are or where I can get them. I know one of my local distributors that may have a lot of these parts. The problem with him is it's mail order only, and our post office has been on strike now for 3 weeks. So there's no parts being shipped. So yeah, we could be waiting a while, especially if even that when I go to Lee's Electronics, he gets all his parts come in by post as well. So he's not getting his stock replenished when he runs out because the post office is shut down. And I know someone's going to say, "Oh, just use a courier." Well, the problem is the couriers are so bloody expensive, and they add all their extra fees on there that a lot of the shops, you know, they're bringing their inventory, they're bringing a lot of parts and stuff in. They get them shipped China Post, because a lot of these parts will come from China. They get them shipped China Post, which is run by the Chinese government, and it costs the suppliers virtually nothing to ship them. That's why you can go onto Alibaba or any of these sites out of China, Banggood and whatever, and the shipping is just like almost non-existent. You know, I bought an IC to fix a TV, a Sony TV, the XPR 6 little gamma correction chip was $1.83, and that included shipping from China. Now you couldn't even ship that part. I couldn't get that part shipped from Vancouver to my house for $1.83 in postage. Never mind the cost of the part. That would be like $5 just to ship a little tiny part. So yeah, the suppliers, when they're ordering their inventory out of China especially, they get it shipped out by post because it's dirt cheap. Anyway, thanks for watching. We'll pick this one up when I get down to replacing parts. We'll catch you in the next one. Bye.